myself, let me just introduce myself and then I will hand over to the next the speaker's part. So myself, Avinash Ravi, I will be a host of this workshop, and I'm the one of the volunteer at of the KCD Bangalore. And KCD Bangalore actually is planning it the third edition of the Bangalore KCD Bangalore on 23 and happening in person on 2nd and 3rd June at Nimnans Convention Center, Bangalore. You can register via website our kcdblr.com or ticket.kcdblr.com. I'll share that links over chat and you can book your ticket there. So we have scheduled many of workshops like this, and today also this is like a second workshop, right? And this workshop will be on storage for the Kubernetes run by the Soda Foundation team. That's about this, and I'll hand over to the Anvit. Over to you, Anvit.
Thank you so much, Avinash, and thank you, Namya. And thanks to KCD for conducting this series of workshop. Hello, everyone. My name is Anvit KS. I'm one of the maintainers of the projects at the Soda Foundation, which is a sub-foundation of the Linux Foundation. We are in the data and the storage and data management space, and we work with a lot of projects. And I believe there will be a lot of interactions through our sessions to all the different projects that we're working on. Today, primarily, we'll be concentrating on the container space. And in that, we're going to be talking about the container storage and backup with Kubernetes. And to do so, let's get started with, let me just share my screen. There you go, that's it. That's the workshop for storage for Kubernetes. It's part of KCD Bangalore 2023, and this is run by the Soda Foundation. Let me just get right into it and introduce to you the first speakers. I'm sorry, I think I made a mistake. I'm sorry, I'm so sorry for that. I clicked on the wrong button. Yeah. So let's get started with the first session for the day, and that is the introduction to containers and CSI. And this is going to be presented by Savita Ashture and Amit Kumar Roshan. Savita Ashture works at Red Hat as a senior software engineer, and she's an open source enthusiast who contributes to open source in every possible way. She's been working, she has working experience in public, private cloud, Kubernetes, Knative, Service Mesh around cloud native projects. She's currently a full-time contributor to the Tecton CD project, and she has presented her work at DevCon 2019, POS 2019, OSI 2018, Kubernetes Forum Delhi 2020, Kubernetes OpenShift India Meetup, and Bangalore CNCF Meetup. We also have with us Amit Kumar Roshan, who is one of the senior system architects at the Soda Foundation, and also one of the maintainers of the Soda projects. He has been working in this industry for over 10 years and has experience developing cloud solutions, especially in PaaS layer on public and private cloud. Currently, he's focusing on the open source ecosystem and Soda Foundation projects for data protection for container workload. He has spoken at MesoSCon, KubeCon, and SodaCon, and other local meetups. With a round of applause, virtual applause, please welcome on your screens, Savita and Amit. Over to you.
So, hi everyone. Welcome to KCD Bangalore. Me and my friend Savita will gonna take a introductory session about container and CSI. Over to you, Savita.
Yes. Hey, hi, hello everyone. Thanks a lot. It's a pleasure to introduce myself and talk about the container basics. So I hope my slides are visible. Can anyone give thumbs up so that I can?
Yeah, it's visible, Savita.
Okay, yeah, sure. Thanks a lot.
Yeah.
Yep. Hello everyone, welcome. So myself Savita, as Anvit introduced, and so today I will be talking the basics of containers, and then Amit will talk about the basics of CSI, and then he will start going deeper and give the demo and all. So moving on, this is the pretty much agenda we have it for today. So basically we will be covering the overview of containers, why containers and its challenges. Then how do we overcome those challenges of containers using the orchestrators? And one of the popular orchestrators we will be talking today is Kubernetes. So we will be basically covering the concepts, basic resources, and then architecture, very high level. And then Amit will talk about the CSI introduction, its architecture and internals. Moving on, so before we get to know about the containers, let's understand like why containers. So before the containers, how virtual machines help us to do the develop and deploy applications. So basically, virtual machine is a compute which uses the hypervisors to run the programs and deploying the apps. So as you see on the diagram that we will be having a infrastructures, and with the help of hypervisors, we can able to create any number of virtual machines. And each virtual machines have its own operating system, and they are independent of each other. And though they are running on the same infrastructure. So some of the challenges with virtual machines we face is like high infrastructure cost, less efficient in the resource utilization, and it takes its own sweet time to boot and come up into a running state. And there are some operational overhead also with the virtual machines. So in order to solve these challenges of virtual machines, so we started using the containers. But I'm not saying that with these are kind of a drawbacks. No, these are kind of a challenges. Every tech stack has its own challenges and own advantages. Though it has a challenges in VMs, but there are a number of use cases that cannot be going to solve without the virtual machines. But there will be some scenarios where virtual machines will become overhead for some use cases. So that's where containers play an important role. Basically, container is kind of a way to provide the ability to run your application program independently on a single host machines. So we can, if you want to just understand in a very pictorial view, we can just assume that virtual machines are developed on top of infrastructure, and in a single virtual machines we can have a n number of containers running. How on infrastructures one virtual machine is independent of other, similarly in a single virtual machine containers are independent of each other and they run in its own isolated environment. So those kind of isolations and everything we can we can do with the containers. And also it solves the challenges of like reduce the boot time. I mean, container doesn't take any time to start, and it does the very efficient management in the resource utilization and very less infrastructure cost. So these are the few challenges we observed in virtual machine can be overcome using containers. And basically containers uses the image, which is nothing but the immutable file, which actually contains the required dependencies, library, binary, and code. It's kind of a bundle where you can just use anywhere, wherever you want to run the containers. And that immutable file can be created using the template called, or we can say text document called Docker file. And Docker file has its own instructions to write those lines. And the container basically uses the concept of, or like the Linux kernel concepts, so which are like namespaces, C groups, security component, and many more. Some of the runtimes which containers, whoever going to write the container engine, they should follow the Open Container Initiative and the container runtime interface. So basically the CRI is mainly used in Kubernetes a lot in order to write the interfaces and all, in order to write the container engine. So some of the challenges, as I mentioned earlier, like every tech stack has its own challenges and pros and cons. So challenges like how do we handle the large scale of containers? How do we maintain those? How do we handle the failure state, right? How do we recover the failure state of the containers when there are like thousands or 10,000s of containers running on your virtual machines? How do we handle this rollout rollback mechanism without any downtime? How do we manage the network challenges in an efficient way? How do we handle the storage management? Right? Though we can do all these things manually, it requires some manual intervention and it is very hectic. But when we talk in a production use cases and all, it will be very challenging just to use the container, right? So that's where we have these orchestrators, which help us to overcome all these challenges and do our best in a production environment. So there are multiple number of container orchestrators available today, but Kubernetes is one of the major usable orchestrator tool, we can say. So basically, it's kind of a tool which automates much of the work which are required to run the containerized workload. And Kubernetes is best among them. I'm not saying that Kubernetes is the only solution, but it again depends on the use case scenarios, right? And Kubernetes is nothing but it's an open source project or open source tool, we can say, which comes an excellent scheduling mechanism, resource management in order to deal very efficiently for the containers, and it will help us to tackle the challenges of containers today. So some of the core resources with the help of core resources, we can deal with Kubernetes and we can use day to day. So those are like containers, pod, deployment, services, volumes, and namespaces. And we already talked about the containers. Let's just understand about the pod, which is very basic entity in Kubernetes. So as I shown in the diagram, pod is a template, or we can say a resource which actually contains or manages multiple containers. And with the and pod help us to do the sharing of resource namespaces and file system using volumes for those number of containers within that pod. Now, how do we manage the life cycle of these pods? So that's where the controller play important role in Kubernetes, which is nothing but the deployment. So the deployment is a controller which actually manages the life cycle of the pod. So in a container, when we saw the challenges, like how do we manage the number of containers, how do we handle the rollout, rollback? So similarly in Kubernetes, pod is very similar to containers. In order to handle the life cycle and in order to manage those number of pods, we have the deployment controller here. And in order to specify how many pods we want, in order to mention like the exact value, how many number of pods can be run within a deployment, we can specify using the replicas entity. And this deployment controller help us to do the rollout, rollback, health check mechanisms, and like in order to manage the life cycle of the pods. And these deployments are very useful for stateless applications. And in order to manage the stateful related of applications in Kubernetes, we have another resource called stateful set. Now, once we deploy our application, once we have everything ready, how do we access that application? In order to access the application, we have another resource called service. So service is divided into 3 parts based on the user scenarios. I mean, like if you want to access your application within the cluster, use the cluster IP, across the cluster node port. And if you want to expose its outside world, we can make use of load balancer service type. And these services are directly have the information of the pods with the help of endpoint slides. So one of the major use case or the major usefulness of this service is like we no need to maintain the IPs of individual pod. Those kind of overhead can be solved by services as it deals with the DNS names. Now, as I mentioned that a single deployment can have a multiple pods. So there will be a scenario where in a one pod, there will be multiple containers and they share the resources. Resources can be anything in the form of a logs, data, it could be anything. So how do we manage those sharing of data between the containers within the pod? So that's where volume play important role in order to manage all those dependencies and all those data accessibility between the containers. And again, in volumes, we have a types, ephemeral and persistent. And if I want to tell in a layman term, it is like a local and like permanent and temporary. So one is like within the life cycle of the pod, only volumes will be maintained over there. But if we have a scenario where we want the data even after the cluster dies or even if the pod dies, so in those cases, persistent volume will be more useful. And today we have an integration with number of cloud providers as well. And there are number of ways to deal with this volume, basically the persistent volumes. And one of the major part we wanted to cover, which is isolation. So let's take a scenario where in a cluster, I will be having a two user, and those two users don't know about each other, right? They just got the cluster and they want to do some operations, basically like creating the pod, creating the service and accessing that application. Now, let's say user 1 has created the pod foo, user 2 created the pod bar, right? User 1 now start creating the service called demo, right? It will be success for him. But again, user 2 starts creating the service again with the same name called demo, because he doesn't know that in that cluster there is already another user who is creating a service with same name. So he started doing that and it will fail for him. And it will be surprise for him, like, okay, this is a cluster and I am the only user using it here, right? So in order to avoid these kind of issue or kind of a collisions, so isolation play important role. And that isolation we can achieve using the concept called namespace. So namespace, if I want to say in a like very pictorial view, it's just assume that in a virtual machine, how containers are independent of each other. In Kubernetes world, namespace provides us the similar environment. So let's suppose in a cluster, if you have a 3 namespace, assume that those kind of a 3 different, you got the environment to do your work. So that's where what users start doing is like user 1 create the namespace first, and user 2 create the pod foo in that namespace. And another user also started doing the same way, create the namespace and start doing the pod creation of over there. And now both users start creating the demo service and it will be success for them. So this namespace provides the isolation such a way that in a cluster, we can, if we create a namespace that provides a complete isolation, and within that isolation, we can do whatever we want, that will not affect to the other user. So that's where we call sometimes tenant-based scenario in a multi-cluster environment and all. So those kind of things we can achieve using namespaces. So now let's talk about brief about the overview of architecture. So similar to other architecture, Kubernetes architecture also has a master node architecture, where in master control plane components will be deployed, and in a node data plane components will be deployed. So control plane is nothing but doing some platform level of logic, and data plane basically manage the life cycle of your containers. So in a control plane, we have a component called Cloud Control Manager, Controller Manager, API Server, Scheduler, etc. And in a node, we will having a kubelet, kubeproxy, and some other runtime environment, depends on the scenarios. Right? So basically, Kubernetes API Server is the one object or one component which is accessible to everyone, and each individual components interact to the API server, and that API server is gives us the end user input using the CLI called kubectl, or graphical user interface called dashboard. So or using the REST APIs as well. So all as an end user, I can connect to this Kubernetes cluster via the Kubernetes API server. This is kind of a gateway, we can say. And each information to the Kubernetes API server, each module does the communication. So basically, cloud controller manager does the controlling parts, like as I mentioned, deployment, stateful set, replication. So these are some controller which actually running in a cluster and try to make sure that actual state matches with the desired state. Right? etcd is, as we all know, that etcd is the data store which maintains the data. Scheduler does a very critical algorithm here, which does the scheduling of your containers based on the available resources and based on the healthiness of the node and all those stuff. It has done a lot of number of algorithm here. and we have a kubelet which is agent in each and every node, which actually communicate with the API server in order to make sure that, in order to give information about the healthiness of the node, healthiness of the container. If container crashes, what is the reason? So all those information will be sent to the API server using kubelet, and kubeproxy is for doing the DNS related stuff. Yep, that's all about the high level architecture. Now I would like Amit to take over from here and talk about the CSI and many more about that. Thank you.
Thanks, Savita. Thanks for the wonderful session. So could you please stop sharing? I'll start.
Yeah, sure. Sorry. Yep, you can start.
Just my slides visible? Maybe someone can confirm.
Yes, it's visible.
Okay. Thanks.
Yes, sir.
Okay. So Savita talked about all about execution unit. So Kubernetes containers, these all entities mostly talks about the execution of your program, how to manage your program and how to manage your execution part of it. But I believe no system completes without persisting any data when it gets executed or in a real runtime. So that's where the storage system comes into the picture. So CSI is a interface, open standard. It provides an interface uh, so that there will be coordination between the storage system and the container orchestrator system. So much so that the there will be some interoperability. There will be a vendor agnosticness will be there. So that's all about CSI. So initially, prior to CSI, each and every container orchestrator, which means Kubernetes, Mesos, Docker, whichever parties get involved in managing the lifecycle of the container, they have their own way of providing storage to the workload managed inside the orchestrator. And there was some problem with those interfaces. Some of the problems listed here are basically each and every storage provider, if they have to get integrated with any orchestrator, have to write the different interfaces, different drivers, so that they can provide the storage system to the workload. Most of the implementations or the most of the drivers are entry implementation within the container orchestrator code. Okay, some of the issues are like storage driver, basically because they are entry, so they the development life cycle of the storage driver has to be aligned with the container orchestrator release process. Okay, that will put a lot of pressure on the storage driver developers. And then again, there are these are the issues from the storage point of view, but there are some issues from the container orchestrators also, like because these drivers are mostly written in entry, so there will be, because and the code will be running within the process of your container orchestrator, so there will be issues with reliability and security. So that's where CNCF took an initiative and started developing. They created a work group and started developing a common standard which can be followed by each and every storage provider and each and every container orchestrator. If they follow, they will be able to communicate with each other seamlessly. So that's the background of CSI. Some of the goal of CSI which has been taken care are interoperability. Like once a storage provider they have written the driver that can be plugged in into any container orchestrator whoever supports the CSI standards. Okay, this again is a this is something which is helping storage provider, but at the same time, your container orchestrator gets vendor neutral neutrality basically. So they do not have to worry about how the things are working or not. The interfaces are well defined, and the reliability, security issues will be taken care of. Now, the main focus areas are like to develop a specification through which the container orchestrators can, with the help of a storage driver, can be able to provision volumes and deprovision volume at the same time dynamically, attach those provisioned volume to the node, mount those volumes to or unmount the volumes to the node. And then also the CSI standard is all about block and the file system volumes. There are some more standards for, especially for object storage, which is Koshi, but we are not going to take we are not going to discuss those standards here. We are only focusing mostly on CSI. So basically CSI is all about block and file system volumes. Also there are some storage provider which is very local, like device mapper and LVM. So there the standards has also taken care, so that if you write a driver, the driver can also be, the CSI driver can also be written for the device mappers also, like local storage providers also. Okay. Also if it is a volume, the snapshot is like integral thing of it. So creating and deleting a snapshot like primary volume, primary storage provider, the creation and deletion of snapshot is also part of the CSI standard. Okay. Also there are some more additional capabilities added, like whatever snapshot are taken, you can create a volume out of it. You can also resize the volume with pre-existing volume. So these are the some focus areas which has been taken care in the CSI. Okay. Now we are moving on to the CSI architecture. Now, because CSI has to cater with multiple container orchestrators, so the deployment of CSI plugins bound to vary, like because each and every orchestrator will definitely deploy their workloads in a different way. So considering that aspect in mind, uh, uh, the standards has been made in such a way that it is pluggable in approach, and also divided into two major plugins. One is node plugin and other is a controller plugin. So the node plugin is mostly will be running on the node side, where the actual workload is going to run. And it will be mostly handling volume provisioning, mounting and unmounting part of it. So sorry, volume publish and mounting and unmounting part of it. Now there is there are something called controller plugin. This controller plugin is mostly uh, are running in the management sections of the complete cluster, and they will be handling provisioning, deprovisioning of the volume, maybe the resizing and size, creating a snapshot. All those aspects has been taken care in the controller plugin. So considering this deployment architecture, right, mostly the plugins are divided into two, like plugins can be categorized into four major sections. Like one is a centralized and the other one is a headless. So centralized is where let me just take here. So this is one of the example of this centralized architecture, where your controller plugin will be running on the master component. Okay. And all the provisioning, deprovisioning, snapshot creation, volume resizing and everything, all the management aspects will be taken centrally managed by the controller plugin. But at the same time, the node plugin will be running on the host side, and the container orchestrators would mostly using this node plugin for mounting and attaching the volumes to the node. The second thing is which is a headless unit, where controller plugin and the node plugin both are running in the each and every node of container orchestrator. So the container orchestrator will be each time connecting with the respective node, uh, uh, respective controller plugin of the node, and they will be orchestrating the volume and will be attaching. The node plugin will be taking care of the attachment part of it. Okay. the the split component and the unified plugin is some way of packaging the component. Sorry. Packaging the node plugin and controller plugin. So if it is packaged within the same process, it is called. Hello.
Game बंद करो game. क्या कर रहे हो?
Hello. Okay.
Yeah.
Okay.
Request non-speakers to kindly go on mute. Please avoid any interruptions. Thank you.
Sorry guys, just give me a minute. Okay. So as I was saying, if two components like node plugin and the controller plugins are packaged within the same process, those are called as unified plugins. And if it is the packaging is done in such a way that they are split into processes, so that is a split plugin architecture. So CSI standard has taken care of in such a way that most of the deployment of your plugin as well as the workload, right? The workload who needs the storage provider can be taken care. Okay, so mostly the centralized approach is taken care, and our Kubernetes also follows the centralized approach itself. So we have this is like how the CSI has fit inside the Kubernetes or Kubernetes, how Kubernetes supports CSI standards. So what Kubernetes has done is to support controller plugin and node plugin. What Kubernetes says that each and every storage provider can write their own driver. Okay, and Kubernetes CSI subsystem provides the sidecars. You see these pink color boxes are the sidecars which will be given by the Kubernetes subsystem. Okay, these sidecars are the actual entities who will be interfacing between Kubernetes interface and the CSI standards. So all the drivers, the storage drivers, will be implementing your CSI standards, which is in this pic, it is green color one. So they will be the sidecars, right, running alongside your driver will be taking care the translation of Kubernetes to the CSI standards. So the storage driver has to just take care of writing the CSI standards and deploy the sidecars, Kubernetes provided sidecars along with your driver, and you will be able to provision any volume or deprovision all the volumes, and will be working fine with it. So okay, maybe. Yeah, so if you see the complete architecture, these are the master components of Kubernetes of the right side. So mostly your all sidecars will be communicating with Kubernetes API server for interfacing point of view. All the translation of the volume, PV, PVC, storage classes, and everything will be translated by this guy, and basically it will be pulled from the Kubernetes API server, translated into Kubernetes CSI standards, and will be sent a gRPC calls will be initiated to the driver, and that will be done through Unix domain socket. So all the communication between the sidecars and the CSI driver in Kubernetes are done through Unix domain socket, and the protocol is gRPC protocol. Okay, so but what they do internally is they expose an empty directory volume inside a pod. So this complete represent one pod. So within the pod, you will be having two containers. One is sidecar and the actual driver, and they will be communicating on Unix domain socket, and the Unix domain socket will be placed centrally to the empty directory volume in controller plugin. But at the same side, for the node plugin side, it is basically communicate. The kubelet is going to communicate with the node plugins side of CSI architecture. So mostly it is supposed to be get deployed on each and every node. So it is deployed as a daemon set. So there will be a sidecar called node register. So this helps to communicate with the CSI sidecars and will communicate with the kubelet to register the CSI drivers, and those will be reflected inside the system, that each and every on which all nodes the CSI drivers are installed and stuff. So that will be communicating. So through the CSI and once it has been registered, right? So kubelet will be straight away communicating to the CSI driver container for mounting and publishing the volumes to the Kubernetes system. So this is how the CSI standards are fit inside the Kubernetes system. So okay. I'm just taking you guys to some of the internals of CSI standards. Basically, the complete system divided into 2 plugins, and those plugins are further divided into different services. These services are basically the interfaces should be get implemented by each and every driver. So basically, we have currently 3 services. Recently, a new service has been also introduced for doing group management activity, like if you have to take a group snapshot or something. So that has also been introduced in the CSI standard. So currently we are going to only discuss about the 3 standards which were working earlier. So one service is identity service. So mostly this identity interface. So this is the identity service. This identity service is a part of both your controller plugin and the volume node plugin. So maybe if you can see in this picture of Kubernetes CSI implementation, CSI support system, this acts as a controller plugin, and this one acts as a node plugin. The daemon set part will be node plugin, and the stateful set, like a management entity, will be acting as a controller plugin. Oh, you can see over here also. Okay, so yeah, so the identity part of the interface is basically, by the way, all these services are gRPC interface. So you can see all the RPCs over here. So identity service is interface should be implemented by controller plugin as well as the node plugin, and the key role of the identity service is to provide the identity information of each and every driver. So you can see the get plugin information, which is about the getting the plugin name, like what provider it is, or the which version of provider it is. So all those information will be fetched by either the controller plugin or the node plugin through the identity service interface. The second will be the what all capability each and every driver will have. Okay, so all those capabilities will be over here, whether they support volume mount, volume publish, unpublish, attachment, detachment, whether they support this functionalities or not. All those capabilities will be fetched either by node plugin or the controller plugin through the get plugin capability interface. This probe is all about the health management. So as the identity service is part of both controller plugin and node plugin, so whether those services are up and running and properly performing or not are basically managed through this probe. So each and every in the case of Kubernetes, so this externals sidecars, right? The Kubernetes provider sidecars can periodically poll to get the probe information from each and every driver, so that they can actually manage the life cycle. Whether if let's say your driver is down, you can take action like the complete pod should be down, or the state of the complete pod should be down, because if your driver is not available to serve you, there is no point of further continuing the pod. So you can completely bring it down and then bring back it again. So that was the use case of Pro. Okay, now we have some services like controller service. This is all, this services mostly caters the interface calls which is related to the management aspects of the volume, like creating a volume, deleting a volume, so controller publish volume, which is being called like if a particular uh, a particular workload will be assigned to a particular node, and that workload is consuming your volume. So this function, this RPC will be called, so that the controller interface can do some API calls to the backend storage, and they will be able to perform. And like if some, let's say your volume is being fetched from a particular node, you can have a security policy like enable to access this particular volume on for this particular node only. So to help with this kind of scenario, this interfaces are here. Okay, in the demo section of this, in the demo section we will be seeing where it is being called. So yeah, so this validate volume capability is all about if pre-existing volume has this capability which has been requested by user, that will be requested or asserted by the container orchestrator, and maybe the storage driver has to communicate with the storage and fetch that information whether the assertions are correct or not. If it is not, then maybe it can reply with the information, and container orchestrator can deal with it. So list volumes is all about listing all the volumes which has been orchestrated. Get the capacity of a particular volume is all about what is the current capacity of the volume. Controller capabilities all about the capabilities of each and every controller, what all capabilities supports, whether it supports snapshotting, whether it supports your attachment, detachment, whether it supports your publish publishing the volume or not. So all those capabilities can be fetched and maintained in the Kubernetes orchestrator. Okay, now the creation of snapshot, deletion of snapshot, and this is all CRUD operation for managing the snapshot for each and different respective volumes, which can be done from here. Okay, now the second aspect is each and every volume which has been provisioned can also be expanded. So this capability maybe your storage provider can support or may not support. So if you are requesting for expansion of volume, maybe your provider, if it is not supporting it, the driver can straight away respond back with the not supported, RPC not supported, and your expansion request will be stopped over there and it will be failed. Okay, yeah, controller get volume is all the volumes which will be managed and maintained by this thing. So this currently it is in alpha feature, so currently they are working towards it. Okay, okay, this is the data plane part of services. All the calls managed in this particular service are mostly related to the actual data path, like your volume will be mounted, unmounted, published onto the node. All those things will be done with this particular services. These are RPC services. So this is all about staging the volume, unstaging the volume, publishing the volume and publishing the volume, stage and make the volume ready for so that it can be a new volume can be created onto the node, and then you can also publish the volume, which will be like publishing to the system itself. Okay, this is all about volume for each and every volume, what all the statistics, like this statistics currently supports the bare minimum statistics, how much of memory disk space, IO, and all such stuffs are currently supported. Okay, this is all about node expand volume, so which is a part of coming along side the request coming from the expansion side of it. So if it is not supported, you will be getting a error response. If it is supported, yeah, the volume size will be expanded based on this. And all this is the next two section is all about getting the node information on which the driver is installed, and what all capabilities this driver has. So basically these are the services which CSI standards provide, and mostly they are try to uh, uh, build an interface so that there will be a seamless integration of the storage system with the container orchestrator. uh, mostly I'm gonna take a pause over here, because the next section is mostly about demo, how it is been done in Kubernetes. So before that, if I'm all open to take any query or any stuff which can discuss further. And Anvit, do we have time for that, or I can just straight away switch to demo part?
Excuse me. Yeah. So yes, I think we do have time for it. Right now we are at how much time do we have? I think we should be having time. We should not have a problem with the session. Yeah, I think we have about 5 minutes in your session. So probably if you have some demo, 5 minutes is what we have from your overall session time.
Okay.
5 to 7 minutes. So maybe you can, if you have something which you can demo in 5 minutes, maybe have a couple of questions. But,
Yeah, the demo part of okay. So okay, is it I do does it the session the current session has crossed the demo part also, or
yes,
I have only 10 minutes for the demo?
you have eaten into the demo time. Your demo should have ended by 4. So
Sorry, Anvit, maybe not audible.
am I audible now?
Yeah.
Yeah. So I'm saying that your demo timing was till 4 p.m.
Okay. Oh, okay. Okay. So maybe I can
Maybe
quickly
you can
start.
jump into demo and then we can take the questions.
Okay.
Exactly.
Okay then. Okay. Okay. So guys, before taking you through the demo, I'll just give you the system information for this particular demo. I have installed a kind cluster on the single VM. Okay, and I have used a CSI driver host path. I'm gonna use to demo the volume, like how the CSI standards has been integrated with the Kubernetes. So most of the information I have already compiled and maintained inside the reference document. So you can see the Kubernetes cluster is mostly kind cluster I have installed. The CSI driver is CSI examples. I'm gonna use the example maintained inside the CSI driver host path itself. Okay, you can go through. Maybe what I have done is have given a basic glimpse of CSI specifications. The CSI specifications can be found in this link. Okay, and yeah, the complete Kubernetes doc and sidecars management and driver, like what all drivers are currently supported in CSI, can be seen over here. Uh, so uh, uh, the current system have only kind cluster plus CSI driver host path. So once you see that, the basic thing is getting to know the storage class, PVC, and PV. So the storage class is all about the quality of your volume. So the storage class information, if you see over here, I have just extracted this information from Kubernetes itself. So this involves the information of which provisioner is gonna take care of the volume. If you use this storage class, so your volume will be dynamically provisioned. So basically in Kubernetes there are two way of using volume. One is static volumes, and other one is dynamically provisioned volume. So if static volume is all about the Kubernetes cluster uh, operator guys. So what they do is they pre compile and add the uh, uh, persistent volume into the Kubernetes cluster, and as soon as you request any volume without any storage class, they will be mostly picking from the provided PVs, which will be gonna fit the most of the requirement of your volume. So all the requirements of your volume, so those will be assigned and bounded. But if you are trying to use the storage class, so basically it is a way of provisioning the dynamic volumes. So what it would do is it would be connecting with the provider, which is basically your driver, CSI driver, and they request the CSI driver. Like Kubernetes will request the CSI driver to provision the volume based on those quality which you have requested in the storage class. So basically, this is storage class is all about defining the quality of volume which is gonna be get provisioned, and to which provisioner it will be the policy, like whether reclaim policy, whether the once the volume is provisioned and once it is deprovisioned, right, whether the volume in the storage system should be deleted or it should be retained so that it can be reused. All those informations, right, all the quality of the volumes uh, created, right, will provision, right, will be managed and declared by the storage class. Now PVC is all about the flavor of the volume, like how much of capacity you would need, like a user would need, how much of what is the volume mode, like whether it is a file system or blocks services, or whether what access mode you would need for your volume, like whether it's a read only or read write mode, and also stuffs are basically handled. So PVC is that abstraction which handles the flavor of the volume, and the PV part will be mostly about the actual volume, which is this PV is the abstraction. Actually, it is the actual representation of the volume which is provisioned inside the storage system. So PV is all about all the information with, related to your volume, right? All the information will be available in PV. So, so I have just for who are new to Kubernetes, and so I have just given some like I have introduced the jargons which we're gonna use inside this complete system. Okay. So oh, so currently I'm gonna use the storage class with name of CSI host path SC. The storage class is basically backed up by this host path CSI kts.io storage driver. What it so this driver will help me to provision different volumes. Okay. Now what I need is to request Kubernetes to give me a volume, right? So what I do is PVC is that abstraction. So basically, if a user has to request a volume, PVC is where you should declare inside the Kubernetes cluster, and Kubernetes will work towards to make a PV for your request. So if you see the PVC request, right? It will look little like this, like so. You, as I mentioned, it is like a flavor of your volume request. So you basically user has gonna request like 1 GB of disk space for particular storage system, the access permission of that particular volume, and which quality of volume you would expect to be get created by the provider is basically gets repaired, because the storage class manage all the things which is related to the quality of the volume. So we just specify the name of that storage class. That would be sufficient. So all this information is sufficient enough for Kubernetes to provision a volume and connect with the storage provider driver and provision a volume for you. So what I'm going to do is I am going to connect with Kubernetes. I'm requesting to create a PVC for it. So yeah, you can see the PVC has been created. Now it has been bounded with this particular volume. So this is our PV. Okay, so it has given me 1 GB of volume. This is the access mode. My storage class and everything is defined, and it has been created 4 seconds back. Okay, so if you try to look into the information of PV, right? So it is the complete information that of a particular volume. You can see this particular volume, right, which has been provisioned in backend, right, storage backend, right? You can see that volume has this access mode, this capacity. This is the PVC for which you have created this particular volume. This is the driver for which you have created the volume. This is the volume attribute. This is the volume handle. This is the actual connecting entity between the storage backend storage and your volume. So this is where actually abstraction come into the picture. You see, over here the name of the PV might be totally different. You see, the name of the PV is different, but the volume which is created in backend might have the different name. So volume handle is that representation. So you can also see one of the good feature which CSI provide is the topology support. So maybe your Kubernetes cluster is span across multiple availability zone, or maybe multiple regions. So what you can maybe for your each and every region might have a different storage system associated with it. So what you can have is each and every volume which has been created, right? They will be having an affinity of in which, and we'll be having the information like in which for which region this volume has been created for. So you can see that this is been created for this node. Let's see, these are the nodes currently I have in the cluster. So you see, this is the node. So this volume has been created for this one node. So any workload, right, if has to consume this node, has to be get scheduled on the same node. So let me just, so this is all about volume creation. So what it would have been like in the background, how what would have been done is yeah, as soon as you have requested for PVC, the API servers would have done some processing. Mostly PV and PVC controllers are available over there to process PV and PVC request. So PV PVC would controller would have processed PV C, and they would have created a PV, and the PV no, sorry, PVC would have been further attached and amended with what provisioner it is being requested for. So once the PVC is been given an annotation with that this is the provisioner for which this PVC is been attached to. So the same provisioner will pick that, like these sidecars, right? These sidecars will be watching on all the PVCs. So they will pick only all those volumes which is being requested for to be get provisioned by the respective driver. So this sidecars will be picking all those requests, like PVC, the complete request will be going over here. This will translate the PVC request into the CSI driver request. So this, the first request would be to create a volume. So basically it would do what it would do is to call this API call create volume. So it what the sidecars would do is to create a create volume request object and further call a create volume RPC call. So which will be processed by the CSI driver. It would connect with the backend storage, okay, and will provision a volume and will hand over the volume information to the external storage, and this external storage will further create a PV and push all the information like attribute handling and everything. All the information will be added to the PV. So this is what has been done in the background to create a particular volume. Once you create a like do a PVC request. Now this is all about like provisioning a volume. what about, let's say I have to consume this particular volume. So what we do is basically we define this particular volume in pod or any workload execution entity like deployment, stateful set, replica set, and all such things. For sake of simplicity, what I'm gonna do is I am gonna use pod.
Amit.
Yep. I know I'm just crossing the time, so maybe.
No, we've taken up the quiz/break time also, and we have just 3 minutes left. So you might want to just wind this up.
Okay. Maybe let me just apply this one, and then we can. So you can see that the new pod is starting, and what I have done in this pod is whatever PVC I have created, I have attached that particular volume with this particular pod. So for that, what we have is so once it is done, so now you can see that the our pod is up and running, and it would be consuming our volume. So so this is it from my side. I think I have taken more than what I expected to, from my side, but so yeah, please please feel free to connect me. We can discuss more on this. So
Amit,
yeah,
there were questions whether we can share the slides later on.
yeah, yes, sure, I can share the slides. Yes,
we'll be sharing. I think we'll share all the speaker slides via common folder to all the registered attendees.
Yes.
Okay, great. Yeah.
Okay.
So
thanks, guys.
Are there any questions? Maybe we'll just take a couple of questions. Well, if there are no questions, thank you, Savita, and thank you, Amit.
Yeah, thanks everyone.
And let me just. Yes, that was the introduction to containers and CSI session by Savita Ashture and Amit Kumar Roshan, and was followed by a hands-on working of the CSI by Amit Kumar Roshan. Thanks once again, and we will now head on to the next session. It was supposed to be a quiz. We'll take it up sometime in the middle because we're just getting started. We're just getting warmed up right now. So what we'll do is, let's now take up the next session, which is data management with CSI, snapshot, and more. This session will be conducted by Sushanta Kumar, who's the lead architect and a project manager at the Soda Foundation. Let me just quickly give you a brief introduction about him. Sushant is a lead architect at the data management as the Soda Foundation team. Currently, he's working on the container data management project. And prior to this, he's worked on the PaaS platform for cloud native application and also has exposure on different user access protocols for the network devices. Here with data management with CSI and snapshot and more is Sushant Kumar. Over to you, Sushant.
Thanks, Anvit. Am I audible?
Yes, you are, Sushant, with a beautiful background.
Let me share my screen. Is visible or not yet open?
No, Sushant, it's not yet open.
Okay. Okay.
Yes, it's sharing now.
Open, right?
Yeah.
Okay. Okay, hello everyone, good evening. So as a part of continuation of what Savita and Amit had taken, so that is with respect to data management with the CSI. So what and all aspects of data management currently we can handle with CSI, and what are the scopes to which can be explained in future. So means which can be achieved in future. So in first part, I'm going to take you through the some of the data management aspects that can be achieved through CSI. And with me is Praveen. So he will help us to know or help us to see how exactly we can achieve these things in a Kubernetes cluster. So without taking much time, I'm audible, right?
Yes, Sushant, you are audible. Just to give everybody a brief introduction about our next speaker as well, let me just talk about him because I think I thought it was the next session. We also have with us Praveen Ranjan, who is also a senior system architect with the Soda Foundation. He holds an MTech degree from the NIT Trichy and has published multiple papers in international conferences, including IEEE. He's currently focusing on technology and ecosystem development for the Soda Foundation projects like multi-cloud and container data management. He will be conducting the CSI snapshot hands-on seat working along with Sushant with the data management and CSI. Over to you, Sushant.
Yeah, thanks, Sandeep. So before going to data management, CSI aspects of data management, so some of the key challenges data that will come into our mind with respect to data management when we think of any application, container-based application. So these are some of the obvious challenges, like containers are ephemeral, but like Amit mentioned, one of the key aspects of containers is about the persistent storage, persistent volume, and thus by the entire CSI is getting the traction. So data is not ephemeral, but containers are. So some things to be done or some things to be taken care when we deal with the data for containers. And more or less applications are stateful. That means, yeah, it is not necessary like every application. When we talk about containerized applications, we should talk about data. It may not be necessary, but more or less, when you take a real-time applications, always there is some aspect of data persistency that is associated with the end-to-end use case of an application. So persistency is a key requirement. And when we talk about persistency, the storage system comes into picture, and storage system comes with the different capabilities, different parameters. So, and the coexisting storage systems in a given cluster for different use cases. So all about like how we can I can have, or how these storage systems can coexist in your system, and how you can leverage the storage system to fulfill the storage needs for the Kubernetes application. So these are some of the key challenges that comes into mind. So in Kubernetes, we have to talk about Kubernetes. So the key thing or the basic provisioning, that is basic provision with respect to data management, or that is provided is with respect to snapshot. So snapshot helps us to achieve some kind of protection of your data, and so that this is one of the key things that is available in CSI as of today. So what does CSI snapshot do is CSI snapshot, volume snapshot is nothing but a snapshot of a volume at a given point of time on a storage system. So the storage system will give you a volume, and this volume you want to take a backup on the same storage system itself. So in this particular case, the system volume snapshot feature can be used. So this feature is achieved using some of the objects such as volume snapshot content, and volume snapshot class. So we will go through the details of what are these objects and why are they needed, and their significance in the overall volume snapshot mechanism. The first object that comes to our mind is volume snapshot class. This is analogous to whatever storage class that Amit explained. So which basically mentions some of the quality parameters and some of the information about information which need to be taken care while taking the volume snapshot. So this is analogous to storage class, wherein we mention for which CSI driver we are creating this snapshot. So thus it helps us to map whenever this particular snapshot class is referred, it helps us to map like which driver exactly this snapshot refers to. And the second one is the specification through which we ask the Kubernetes system to take a volume snapshot. So this is another custom resource definition. So wherein we will be telling like which volume you want to take a snapshot. So you can see in the source, we have mentioned persistent volume claim name. So that means for the volume PVC test, we want to take a volume snapshot, and which volume snapshot class we want to use also we have specified. So this will help us to take the snapshot using the given driver. And third, snapshot content, which is actually created by the system. The other two are created by the user when he performs the volume snapshot operation, whereas this particular object is created by the system upon the request for the volume snapshot. So this snapshot is nothing but this is a mapping object which helps us to get the details of what volume snapshot this represents. So where here we can see like which volume snapshot class we have used, and for which volume snapshot, what is the volume snapshot object to which this content refers to, and also at the source side or at the backend side, what is the ID or the handle that has been given to this particular volume snapshot. So this is you can think like this is a mapping or the reference object which helps us to correlate all the input we have provided while creating the volume snapshot. So these are three key custom resource definitions which we should be aware of when we think of a volume snapshot flow. So this is another small aspect of volume snapshot class. Like we have seen when we are creating a volume snapshot, we should be mentioning a volume snapshot class name. So suppose if you if you do not want to have any customization with respect to your volume snapshot specifications, you can create a volume snapshot class and make it as a default snapshot class, so that this will be always taken for this particular driver. So this will be always referred as a default snapshot class, and you don't need to mention it every time when you do a volume snapshot. Okay. So in our previous session, we have seen like in Kubernetes, the basic concept is about some resources and some set of controllers to handle those resources. So similar thing holds good here also. So when it comes to snapshot, so there is a controller called snapshot controller, which helps to take care of, which helps to handle volume snapshots. So moment user create a volume snapshot object, the snapshot controller will be watching for the creation of such objects, and moment it gets any notification for creating a new volume snapshot, so it will go ahead and create a volume snapshot content. So that is the job of this controller. So it basically keeps track of all the volume snapshots that are to be created in our system. Another aspect is with respect to sidecars. So we have seen for the provisioning, we have different sidecars, and attaching, we have a different sidecars. Similar thing holds good for snapshotting also, the extension of the same sidecar pattern here. So for volume snapshot, also we need a sidecar, so which will run along with our driver. So the basic duty of this snapshot or this sidecar is that whenever some volume content has to be is created, if some particular action has to be taken care from this particular driver, so this will help us to get the notification and facilitate to our driver and get the snapshot done at the storage side. And this is an aspect I mentioned is not actually with respect to the usage of a snapshot, but actually with respect to the implementation or the the thing that need to be taken care from the driver if it has to provide a snapshot capability. So our CSI mechanism basically mostly works based on the capability. That means the driver can give the set of capabilities which or set of functionalities which it is capable of doing, and once it mentions like whether it is the set of things that it can perform, so that will help the system to efficiently handle this particular flow. For example, some action is driver mentioned like it doesn't want to perform that option or cannot perform a particular option, then it just omits that operation. System just omits that operation. So here, similarly, if you want to perform a CSS snapshot operation, the driver need to publish say, yes, I can handle the snapshot by mentioning the create delete snapshot capability. So once this is mentioned, so this driver will be considered by the system whenever there is a need for volume snapshot feature. Having seen all these objects, let us see a end-to-end flow where all these objects will come into picture and how the user achieves this snapshot feature. So as you can see in this diagram, the snapshot or the volume snapshot object is created by the user. Upon creating this object, the snapshot controllers will help to create a volume snapshot content. So whenever the volume snapshot content is created, the sidecars will help to identify this and will help to get the snapshot created from the vendor side. So this is how we will create a snapshot in the system, and this snapshot will get a reference and we will be able to see all these things at any point in the system. And whenever you want to restore from this particular snapshot, so you just mention, you just create another volume in terms of creating a PVC and mention actually which snapshot you want to use it for creating this volume. So whenever you mention this snapshot, the new volume will be created using the snapshot, and system will have another volume which is created out of the snapshot. And this newly created volume can be used by applications, and it can actually go back and refer to the earlier snapshot that is taken, and thus by referring to the old data which it was dealing with. So just like snapshot, another feature that is provided in Kubernetes with respect to handling the data or with respect to protecting the data is the volume clone. So clone is also clone is like duplicating the existing Kubernetes volume, and thus by giving the feeling like application using another new volume, like as if it was created newly. So differences during the provisioning time, exact copy of the source volume is created instead of creating an empty volume and provided. So this is the clone. This is about the clone feature. And here, when we are creating the clone volume, unlike mentioning the snapshot name, we will be mentioning an existing PVC which you want to refer itself as the data source input. So this is another way by which you can take a copy of the volume and operate on that in your application. So that's all from the snapshot and the volume feature from Kubernetes aspect. So whatever we have seen, we are going to see a demo from Praveen, wherein we will see how do we do all these operations and how we can realize this feature in a Kubernetes cluster. Before that, I just want to know at this point of time, if you have any queries to discuss, we can quickly check and then we can move to a demo. Hello, Praveen, are you there?
Yes, Sushan, can you just click on the hide option of the top sharing down there?
Oh, okay. Okay. Okay.
Thank you.
If no questions now, maybe Praveen, are you there?
No, Praveen is dropped right now. Let me just check. Maybe he's having some network trouble. Let me just check with him.
Okay, okay. Maybe you want to connect from different device.
Yeah. So he's connecting. I think he had some network trouble, probably. Not sure,
Okay.
but he's connecting.
Can you hear me?
Yeah, Praveen.
Very minimal sound, I think.
Okay, okay.
Yeah, better now.
Okay, good. Okay, so hi everybody. Probably I will share my screen and will try to show the demo what Sushant was talking in this meeting,
Praveen, there's a lot of lag.
and then we'll discuss about this how the snapshot feature works and all. So let me share my screen.
Okay.
Okay, so I hope everybody can see my screen, and
I think it's
please
still coming up. It's still coming up.
It's loading.
Anvit, can you see my screen?
Praveen, I think there's some network trouble on your end. The screen is still loading and your voice is kind of cracking in between. Praveen, I think
Okay. Actually, just now power cut happened in my society.
looks like Praveen is a victim of the unseasonal Bangalore rain. Uh, Probably some network issue, some power issues on his side. Sushant, do you have a backup of this?
Can you hear me?
Yes, Anil, we can hear you, but
Yes.
Barely, Sanil.
Hello.
yes, Anil, please speak up.
Hello, Anvit.
Yes, Sushant?
Yeah, Praveen has some network. Maybe we can go ahead with the next one and probably come back to the demo later.
Oh, okay. Is that so? Sanil,
Hello, Sanil.
Yeah, Anvit, can you hear me?
yes, Sanil, I can hear you now.
Okay.
Sanil, we can go ahead with the next part of it. And because Praveen has some, due to power cut, the Wi-Fi connectivity issue is there. So
Okay.
he is reconnecting. So once we are done with this third part, right, probably we can come back to the demo.
Sure. So you mean I can continue session, right?
Yes. Data protection.
That's fine.
Yeah.
That's fine. You're able to hear me, right? I'm not switching on my video.
No,
Okay,
your voice is very clear, Sanil.
Yeah.
Okay. Anyway, I'll not switch on the video.
Yeah, let me just. Sanil, I've started sharing your presentation.
Okay. Yeah, thanks. You're able to hear me, right?
Yes, Sunil. we
Anvit?
can hear you.
Hello, Anvit?
Sunil, we can hear you.
I'm so sorry. I kept speaking on mute. I am a victim of old habits. Let me just quickly give me a moment. Give me a moment, please.
Anvit, you need to keep it unmuted because I need your help to move the slide.
Got it. Okay, so before we do that, let me introduce to you our next speaker. Until Praveen comes back, we will be continuing with the next session, and that session is on one of the projects from the Soda Foundation, which is the Soda Kahu project. And this next session is on Soda Kahu and container data backup now and next, which will be conducted by Sanil Kumar. Sanil Kumar D. I'm sorry, I think oh, I'm so sorry. Am I sharing the wrong screen? Are you still seeing?
Now the sharing is gone. Sharing was good.
Oh, I'm sorry. Okay.
So that was a good example.
Okay. I'm sorry about that. But yeah, I'm just gonna. Okay. Uh, this just goes to show how long it has been since I've done virtual meetings. I'm so sorry about this.
I think Anvit, it's okay. You can
Yeah. So I'm just going to introduce to
pull up
you.
my slide.
Yeah, I'm just going to introduce before we. I don't think I'm sharing anything right now, but before we go on, let's just introduce the next speaker, and that is Sanil Kumar D. He is the TOC co-chair, that is the Technical Oversight Committee of the Soda Foundation co-chair. He's leading the effort of building open data framework for the Soda Foundation and has product development expertise in Linux, open source, ARM ecosystem, cloud data management, edge computing, blockchain, and distributed computing. He has incubated multiple open source projects and has multiple patents and papers to his credit. He is an industry awarded technologist. Let me all welcome on your screens Sanil Kumar D with the next session on Soda Kahu container data backup now and next. I'm just going to share that right now. And yeah.
Hey, thanks. Thanks, Anvit, for that intro. Okay, so let's get started. So this session, we will be talking about Soda Kahu project. Why Kahu project in this workshop? Because it's primarily for data backup. In fact, we started with the data protection. As a part of that, the first part is data backup, which is already completed and released. So we'll talk about that. And before we get into Soda Kahu, we will try to refresh about cloud native and what's happening in the landscape. What is there in Kubernetes, and why Kahu kind of project is important. And there are other projects. And also, I'll just touch upon one slide on Soda Foundation, because we have been listening about Soda Foundation. People may be thinking that it's a beverage company. Okay, so let's get started. And we can go to the next slide. Okay, so this is just to scare you people that why we talk about why KCD, why Kubernetes, why a lot of events and buzz around Kubernetes. Because if you see more than 60-70% of the application deployment is moving towards container-based application deployment. What does that mean? Because the applications, it has been monolithic processors and things like that. And then, like I think Savita was talking about pod, right? So it is, the granularity is becoming smaller and smaller. Why? Because you want to do small things quickly, faster, and things like that. I'm just trying to say in a very simple manner. So you want something which can start, stop, resume very quickly. So container helps. Even microkernel. There are different technologies around it. So container is most popular. And why Kubernetes? Because Kubernetes is one of the topmost container orchestration engine, COE we call it. There are other Cloud Foundry, Mesos, and things like that for container orchestration engine. What is container orchestration? It's nothing but orchestrate the containers where your applications will be or workload will be deployed, and then you manage it. So you need to manage the resources, you need to manage the health, and you need to manage the scalability. You want to reduce the resources when you don't need it, when you want to scale it up when you really need it. So those are all can be done in a very systematic manner, in a very much efficient manner using COEs, container orchestration engines. Now, container landscape is growing exponentially. Why I have already mentioned. So this is kind of a landscape which is from CNCF itself. There are a lot of projects which is getting built in and around containers. It can be for networking, it can be for storage, it can be for compute, it can be for memory management, it can be for even visualization, and so on and so forth. So you are at a right workshop, or you are at a right event, because this is the future. Okay, we can go to the next slide. So cloud native storage landscape and trends. I mean, we'll just touch upon what is there in Kubernetes quickly, and then we'll move. Yeah, we can. Okay, so this is just, I mean, if it would have been in person, I would have had some kind of a QSIN interaction. It's very hard in virtual or online. So we have 2-3 terms you have seen, and with, oh yeah. So you, before we getting into this, we will just refresh and go back one step backward to the earlier sessions, that what is CSI, what is cloud native storage, what is container storage. I will try to make it very simple manner, will not use any technical jargons here. So first let's start with cloud native storage. Before even starting cloud native storage, what is cloud native? Okay, nothing, it's very simple. Cloud native means some applications running natively to cloud. That's it. Now, cloud native, what is a speciality? Why people are talking about cloud native? And most of the applications are getting deployed in cloud native kind of an environment. The major key point is that it is distributed in nature. The applications are getting deployed in distributed nature. So you can deploy anywhere. It can be on-premise, it can be in cloud in the sense somewhere you don't know. Okay, I am just giving a very simplified way of looking at it. And then there are some mode of hybrid. Some will be on-premise in the sense in your home or office or whatever, and some will be outside your home or wherever, you know. I mean, you just know the location, but the infrastructures are outside. So what happens is that your applications are getting distributed and utilize the key 4 aspects of cloud deployment of applications. What are them? One is the scalability. Why scalability is important? Because you don't need all the workload capability always. When you need more resources, you need to scale up. When you don't need resources, you need to scale down. What is the advantage? The cost and all the energy efficiency and so on and so forth. So now one is scalability. What is the next one? The next one is elasticity. So you can increase and decrease your deployment. So this is another advantage. Then of course you have flexibility in the sense, what is that? If you don't use it, keep it down, or if you need bigger applications, more resources, or single bigger workload or small workload, microservice in the sense, 2 services into one application, or the workload can be 5 different services and things like that. So you have the flexibility, and also the flexibility can be on it can be on whether you want to run it, certain applications you want to run it on-premise because you don't want to push the data outside and things like that. So a lot of flexibility comes. Another key aspect is resilience, because if something is down, yeah, you can have multiple redundancy things around, either on-premise, cloud, or one cloud or two cloud. There are multi-cloud. I mean, today, more than 70% of the companies are talking about multi-cloud strategy. What does that mean? It means that more than one cloud vendor they are utilizing it. So the cloud native is the applications running in a distributed environment, exploiting these 4 key aspects. So when it comes to container is one way to get this done. It can be microkernel, microservices, maybe declarative APIs and things like that. One key common factor which you can see across these deployments, technologies, is a common API based deployment. So that's what normally called cloud native APIs and things like that. So common API. Now, if you have any storage deployed based on this kind of a technology, using some kind of a cloud native API, and it is running in a cloud native technology, exploiting those things, those aspects, that is called cloud native storage. Now, what is container storage? Because we discussed that container is one way of putting it as cloud native. So whatever storages are connected in that kind of environment is called container storage. Now, like Amit, Savita, and Sushant and Praveen, okay, to talked about the CSI snapshot and CSI driver and all these things, is that in container deployment domain, if you want to connect storage, there is a defined interface. Any container, it is Docker is one type, okay? It can be Rancher, it can be something else. So if you use any container deployment technologies, this common interface can be used. That interface is called CSI. So container storage interface. Please do not see this as a software. This is a specification. You can actually Google and find out CSI specification, container storage interface specification. It's a specification. What is its specification? API specification. Any like application API, it's an API specification. And based on that API specifications, different vendors will write drivers so that drivers can be utilized to exploit their infrastructure, that is storage, for creating persistent storage and so on, PVs for different workloads, which is deployed on those container runtime called pods through Kubernetes container orchestration engine. So this is an end-to-end kind of a view. So CSI is an interface. CSI driver is a manifestation of that API. Okay, let's go ahead. Okay, this is a cloud native stack. So you can see different things on top of it, that you have business logic, and you have the application interfaces or application workload. Then you have runtime, and then you have storage, network. This stack I have put just to position the container storage, because we are focusing on container storage. And if you just click once again, it will show, yeah. So this is where the container storage interface is there. So any say, let's suppose that a container you take, you will have primarily 3 factors. One is network, the compute part, and the storage. So like Savita mentioned, you have the CRIs, the resource interfaces, you have network interfaces, you have storage interface. So we are talking about the storage interface and like data protection aspect of storage interface today. I mean, in this session. Okay. And we can go ahead. Okay, so cloud native storage also. So if you go to landscape, CNCF is Cloud Native Cloud Computing Foundation, which is under Linux Foundation, which takes care of all these Kubernetes projects, CoreDNS, all the container landscape projects are under CNCF. So that is the landscape which I have shown first about all the container projects. Here I just zoomed the cloud native storage projects. There is a section called cloud native storage projects. These are the cloud native storage projects in CNCF. Whatever I have circled are some of the projects part of Soda Foundation. Also, even Soda Foundation you can find in the cloud native storage projects. And with you can go ahead. Okay, so what are we considering in Soda Foundation? So before that, I will just talk quickly about Soda Foundation, and then we'll talk about in container storage. What are we doing at Soda Foundation? Because we have already listened to what is CSI, what is container storage, what is CSI snapshot, things like that, and what we are doing about it in open source about this. Okay, and with we can go. Okay, we can go to the next slide. Okay, this is a crowded slide, so I did not want to add too many slides to talk about Soda. In fact, this the whole slide is spread across some 10-12 slides. I just fused into one. So what is Soda Foundation? Probably some formatting is gone because it is downloaded from the Google Drive maybe. Okay, so this is similar to CNCF. So CNCF, we have discussed that cloud native cloud computing foundation, which takes care of cloud native computing projects. Now, under Linux Foundation, it's a sub foundation in Linux Foundation. Similarly, Soda Foundation is a sub foundation in Linux Foundation. It's launched in 2020. CNCF, a quiz, it would have been an in-person quiz when CNCF started. It's 2015, if I remember correctly. So, Soda Foundation launched in 2020 as a project under Linux Foundation for storage and data management. Okay, we focus on all the projects about data management and storage. So basically, we wanted to create completely an open source ecosystem and bring all the projects related and provide end-to-end quality solutions. So in a very, very simple manner, our goal of Soda Foundation stack, which you can see on the 3 diagrams on the top half on the left-hand side, that is a high-level architecture. The simplified way of understanding this is that any application platform or any application to any storage is our dream. It means that, say, for example, you have deployed an application in Kubernetes or OpenStack or any other application platform, or you have some business applications running like big data or whatever. Can you connect to any storage easily without even knowing what is that interface, that particular interface of that storage? So when you talk about storage, it can be an on-premise storage from different vendors like HP, NetApp, Dell, so on and so forth. So we call it as heterogeneous storage, different vendor storages. It will have different data structure, it will have different protocol to communicate with them and things like that. So we provide a unified interface for it. This is one section of it. Another section is that there are a lot of software-based storage like LinStore, OpenEBS, container attached storage like OpenEBS, etc. How do you connect with them? That also may follow different interfaces which can be unified under Soda. And the third one, most important, is about cloud storages. So how can you connect in a unified manner to any cloud? Because we talked about the companies moving to multi-cloud and things like that, where you will have problems in connecting different cloud vendors, but Soda can provide unified interface. This is our dream. So to fulfill this dream, there are companies come together, different companies, interested companies come together. So they are all partners of this Soda Foundation. You can see in the middle. And then we come together seeing that, okay, this is our goal. Okay, let's come together and then do what? We need to have some kind of software. So that software, we call it we represent in the Soda project landscape. Some projects are developed by us, the Soda Foundation community, and some are from the ecosystem. So they join the Soda Foundation so that there is no fragmentation. Then, of course, we have events, research, etc. as a part of this on data management and storage to understand what is industry trend and where it is heading to, what kind of project is required, what kind of requirements are required. Okay. So based on that, last year, we started a project called Soda Kahoo. Anvit, we can go to the next slide. Okay, so this I will quickly go ahead. It's like Strato is a project which is for multi-cloud. Unified, it will give you multi-cloud, unified multi-cloud interface, and Delphin will give you a heterogeneous storage monitoring like Dell, HP, or different storages. It will give you a unified interface to get the storage monitoring data. And Terra is an SDS controller for provisioning for on-premise file and block. We can go to the next slide. I'm just going faster. And then the project Kahu, which we'll talk about today. And then Como, it's a data lake project. All these are open source. Como, you will not find any code because we are only at the design stage. All other projects, open source code is available. A very, very simple way to get all the information about Soda and Soda project is bit.ly/soda-starter. So, Anvit, if you can send it in the chat, it will be helpful because I can't type now. So bit.ly/soda-starter. So what it will give you, every information, almost whatever you want to know about Soda Foundation, what are the projects, how to contribute, etc. And if you're interested in open source contribution or these technologies, we welcome all the developers to join us and support.
Yeah,
okay, now we talk about data protection and Kahoot.
In chat, Sahil.
Yes, I saw that. Yeah, thank you so much. And Anvit, how much time I have more? Anvit?
I'm sorry, you have about 5 more minutes, Sanil.
Excellent. Okay, I'll take maybe 7 to 8 minutes and then try to finish it. Okay, so we'll go to the next slide. Okay, so this may be offline, you can go through. I will quickly tell you why Kahoot, because we saw there is a gap in the, because all the storage management in Kubernetes happens through CSI. So we saw that there is a gap in the capabilities of CSI specification to handle the data management aspects, like in enterprise storage. Okay, there is a gap. So that's how we started thinking about Kahoot, and there are other projects like Velero or similar kind of projects. And the link what I have put is there is a work happening in Kubernetes also to think about what is a gap and filling it and all these things. This is quite an old initiative. Last 1.5 to 2 years, this initiative is happening. So you can go through this link. Anybody can join and even contribute or suggest and things like that. So if you open that, you will come to know what are the gaps already there. That is where Kahoot kind of projects can fill the gap at the moment. Okay, we can go to the next slide. Okay, we talk about Kahoot. So this is a positioning of Kahoot. We can go to the next slide. We can go to the next slide. Again, next one. Okay, so a few points about our idea about container data management, because Soda has a separate GitHub organization called soda-cdm, github.com/soda-cdm, where we plan to have all the container data management projects. And the first project is Kahoot. You can see the complete code there, and the documentation, design, everything is available there. So our idea is that fill the gaps in the container space in Kubernetes. Our current focus is on Kubernetes, especially on the control plane side. So we wanted to have a global metadata management and the data management pieces, starting from data protection. Okay, and inside data protection, we started with the data backup. Going forward, we will have replication and failover. We can go to the next slide. Okay, so basically, Kahoot will provide the backup and restore for Kubernetes. So in Kubernetes, in a simple manner, if you say, there are two aspects we need to backup. Why do you take backup? To restore, is it? Yeah, yes, it is to restore when you need it. So that there are different ways of restoring it, in the sense without downtime, with downtime and things like that. So restore means the service downtime will be low or zero. That's our idea. So any banking application or any application, something happens to the existing data, still things should move on. So you have a backup, restore it and do it. And the backups are used for various other purposes like debugging, compliance, and all these things. Okay. Replication and backup are two different things. A replication will be almost like a real-time failover. Backup is something like a restoration. So restoration can take some time if it is huge things. So there are different way of recovering things and running it. Okay, replication will be a little more costlier. Backup will be a little less costly. Okay, now on top of this, so I talked about what are the two aspects I missed to tell about it. So first aspect is whenever you have an application in Kubernetes, the Kubernetes configuration about that application, especially about the resources, the configuration files, etc. This is we can call it as metadata. The metadata aspect has to be backed up. Then only you will know about what is that application, right? The next part is that the application always have the data in the PV, where the real data, say for example, the employee data or the the salary information or the cricket score and all these things. So any data, the actual data will be there in the PV where this has to be taken backup. So we call it as metadata backup and data backup, both to be taken for a successful recovery of the application, right? So this is one key aspect we cover in Kahoot. The second point is about O&M. Why O&M? Because we want to automate. Say, for example, a schedule backup and say particular backup or some specific data backup. So because Kahoot supports different granularity of backup namespace, label, cluster level, all these things. I mean, at that pod level, the different granularity, you can take the backup uh, to whichever destination you want, right? Of course, it has to be the recovery point objective that RPO and RTO should be lower and stuff like that. Okay. Yeah, this is just a very high level information that you have an active cluster and standby cluster. Now you take the backup, and using the backup, the pod will be initiated onto the standby, where it can get the metadata and data, and it can start running from there. Okay, the service endpoint will be managed accordingly so that it can move from standby active to standby. You can go to the next slide. Okay, so this is a little more details about Kahoot. So if you see on the right hand side, you have some core services of Kahoot, wherein you have this metadata and volume backup controller. Volume is the data backup controller. And then below you can see a storage provider framework. Why storage provider framework? This is a unique feature, we call it in Kahoot, which will help you to add more and more drivers, the endpoints. Say, for example, we want to support CSI, you want to support NFS, you want support, say, S3. So different kind of providers or protocol to be supported on the storage side, the endpoint side, that can be plugged into Kahoot very easily through storage provider framework. Okay, I'm trying to be very, I mean, in a simple manner. I'm not going into the deep of these interfaces. A detailed design document is available in the GitHub. Okay, and on the top, the blue things are kind of O&M and visualization. You can have your own O&M, or you can use some part of the policy management or scheduling management from Kahoot. Some of the detailed features are on the left-hand side. We can go to the next slide, Anit. Okay, so this current progress probably is little outdated because we have already provided some more features on top of it, and we will be coming up with a release by June first week, the next release. Not only for Kahoot, Soda next release will come. Why? Oh, okay, that's a good question. Maybe I'll just answer that as well. I think in Hawaiian language, it is called guardian. Okay, Kahoot, the meaning is guardian. Yeah, we thought that it is apt for guard your data and metadata. So that's the reason. Okay, so there is a meaning for it. Okay, coming back. The backup and restore features are already there in, and we are also increasing the support, because NFS is out of the box, it is supported, and CSA is supported, and we are also supporting other backends like lane store through CSI, OpenEBS, things like that. So you can see the progress even in our GitHub. The next release will come. And we also have a design meeting alternate weeks. Tuesday, we have a design meeting and community meeting on Friday, where we discuss about all the projects, including Kahoot. All this information is there in that link what Anvit shared. So if you're interested in something on development in these technologies on data protection, please join this the right time, because we are at the one stage, the backup is over. Now we are going to work on replication and other data management aspect, including observability monitoring for Kubernetes, okay, completely on Kubernetes. So if you're interested, you can just join, ask questions in our Slack or GitHub. Okay, we'll go to the next slide. Yeah, so the next plan, we wanted to have some kind of closed cluster backup and restore, and the provider framework support is already there, but we wanted to increase the support to the different kind of protocol, so that almost every different kind of backends can be supported seamlessly. That's our idea. And then automation and orchestration, the O&M, we wanted to enhance so that little more intelligence can be provided as per whatever requirements from the user. Apart from this, we are focusing on the replication as the key feature going forward. Next slide should be thank you slide, I think. No, yeah, join us. Yeah, this I have already talked about. You can just join our Slack, say hi, and say that I want to contribute. Yeah, you are in the community. That's all you need to do. And if you want little more information, that link will help. That link has got everything: Slack, GitHub, project code, everything is there. So the right time to collaborate, now is the right time. So you can join us. And collectively, we can develop not only Kahoot, there are other projects on multi-cloud and things like that. So if you're interested, you can join. Of course, Kubernetes is one of the key directions for us. Okay. Can go to the next slide. Must be thank you slide. Not yeah. Thank you slide is next slide. After that, Srini will show you the Kahoot in action. Means the demo of Kahoot really working. Yeah. Thanks. Thanks, Andrit. Thank you all, and enjoy the rest of the sessions. And please join KCD. We will be there. If you have any questions, we can meet there and discuss on June, I think 2nd and 3rd, I think, right? Or 3rd and 4th. 2nd and 3rd, maybe.
Yeah, 2nd and 3rd.
2nd and 3rd, yeah. Be there. We can meet in person and discuss more about it. Yeah, thank you so much. If you have any questions, you can just shoot in chat also is okay, so that Srini can continue the demo.
Okay, thank you so much, Sanil. Let me just share my screen very quickly. Yeah, now we have a demo of the Soda Kahoot project that will be presented by Srinivas CH, who's a lead architect at the Soda Foundation. Srinivas Chilveri, he has over 22 years of experience in software architecture, design and development, maintenance, and technical management and product management. He has hands-on experience in building and managing products from scratch, and has interfaced with India research team and with multiple nationalities in architecture, design, and management for different and various projects. Here for a demo of the Soda Kahoot project is Srinivas Chilveri. Over to you, Srini.
Thank you, Anvit.
Praveen, are you
Praveen join?
Praveen, will we just check with
Yes,
you?
yes. I joined now. So
Okay.
maybe after Srini, I can share my.
I just wanted to confirm that. So Praveen, hopefully your network holds. Until then, Srini, over to you.
Yeah. Good evening, guys. I'm sharing. One minute. I'm not able to share something. Screen.
Avinash, does Srini require permissions to share?
No, I have given a permission to participation.
Okay, sure.
But share button is disabled. Some issue from my side.
Srini, I think you have to select the screen. Maybe you just check whether it's
Yeah, I have
click on
selected
the screen to
entire
become.
screen.
Okay, you click on that entire screen thing, then I think maybe it is grayed out now.
Okay.
Maybe the click is
Now
not.
we can see.
Yeah.
Srini, it's a video, is it? I think it's a video. Yeah.
Srini, you're on mute.
I think when you share the demo with audio, it mutes the speaker.
Oh, yeah, really?
Just reduce the volume of your video, and you can
Yeah, I
just.
think video anyway doesn't need a volume. Probably you
Yeah.
can.
So probably stop sharing with audio. There's an option of share with system audio. You can stop sharing, Srini, and then when you restart sharing, just disable the audio part. Yeah, when you click on share screen, there's a small checkbox below for share system audio. Don't do that. Just uncheck it.
Okay. Hello. Able to hear me?
Yes, Srini.
Yeah, Srini.
Yeah. Before going ahead, you are able to see my desktop also now? Hello.
Yeah, we can see you.
Yes.
Yeah. In this recorded video, we already have a Kubernetes deployed, and on top of that, we have deployed the Kahu service and the related required storage. We are using ZFS based eBPF, ZFS storage. Let me play the video. So I hope you are able to see the Kubernetes. Oh, sorry, going very fast. Looks like, yeah, we have Kubernetes related components in the kube system namespace, and in the Kahu namespace we have Kahu related Kahu NFS server, Kahu service, and we are using OpenUBS, ZFS provider, and the Kahu NFS provider. So in this demo, I will be going to show. Basically, we will be going to deploy an application, a stateful application, and we will use that application. We will add some data to that application, and we will take the backup. After taking the backup, also we will do some operations on the applications, and then we simulate the disaster, or I can say disaster. I will kill the application so that then we are not able to access the application. Then from wherever we took the backup, from that backup, I will restore, and then we can see after restoring, we can able to access the application, and we are able to see the data which is backed up during the backup, before the backup, the data we are able to see after the restore. So we can see, we can go ahead and show. I will show. Yeah, now these are the Kahoot related components. Just now, as I explained, Kahoot NFS server. Something is happening. I'm not sure. Yeah. Yeah, I think this is better. Now I have deployed a MySQL WordPress with MySQL based application, and after deploying the application, so all the application related pods or containers, persistence volumes are created. We have WordPress application and MySQL application, which is internally used by WordPress. And to access those application, we need a Kubernetes service. We are using the node port, and that is the port which using that we can able to access from the GUI. And if you see, yeah, now we are able to access the application. So now, yeah, we are giving the credentials and some title username to install the WordPress application. So the test site and test site password, and we have to give some email ID to install the WordPress. After installing, we can log in and we can add some posts into that application. So we'll be logging now using the GUI test set 1, 2, 3. So this is the actual WordPress application. So now we will be creating some posts. It is like this. Yeah, first blog is publishing and first blog is creating. So basically we are creating some data and persisting that data and publishing that using that WordPress. And we will be adding one more blog. So we added 2 blogs and published, and the data is persisted in the database and in the and inside the actual volume. So now we can able to see the first blog and blog 2 in the using the GUI. So now we will take the backup using our Kahoot service. So if you see, as previously Sanil sir mentioned, we can able to give while taking the backup what all the granularity we can give. Currently, we are in this demo, we are giving the namespace level to granularity because the application is deployed in the default namespace. That's why we are giving the include namespace as the default. So just I'm taking the backup. So now the backup is triggered. Now we can able to see the backup status. Backup, if the backup is finished. Yeah, internally we will create VBC CRD where we will store some particular information which is required during the restore. So now backup is finished. If you can able to see the stage and status. So once the backup is completed, we will be going to add one more post and publish. So here we will be going to add one more block, and this is after the backup. So we are publishing this after taking the backup, this block. So when we are restoring this after backup block should not be there, because this we are this block, whatever the data we are writing into the volume, it's after backup. This data should not be there after restoring. So now if you see all the three blocks are there: first block, block 2, and block after backup. So now we will simulate the disaster. So basically we will clear the application. Just we will delete the application for simulating the disaster. So we have just deleted the application. So if you see now we are not able to, we cannot see those applications, and we are not able to access from the GUI the particular application also. You can see only Kahoot namespace and Cube system namespace. There is no default namespace. And now if you refresh this one, we are not able to access the actual application. So now we will restore the application from the backup. So if you see that restore YAML file, so we basically we give the backup name from where we took the backup, and we are preserving the node ports so that we can use the same node port after restore also. So there are some particular parameters which we can use. Like storage classes or some particular parameters we can use during the restore, same things. Or we can change also. We can change the namespaces also while doing the restore. But in this demo, we are restoring to the same namespace. So if you see after restore, restore is triggered and restore, we can see the status of the restore. It's just started. So once the restore is completed, we will be able to access the GUI, and we will be able to see the data which is backed up. So if you see that node port, it's the same 32718. Now we can go and see the same application. It should be accessible. Yeah. Now if you see the data, only we can able to see block 2 and first block. The after backup block is not there because before that itself we took the backup. There is the backup point or snapshot copy will not have the after backup data. So now restore is completed. So this is a basic demo using the stateful application. So if we have any queries, questions on anything related to CSI, Kubernetes, Kahoot, or Kahoot demo, anything, please do. We can discuss if time is there, or you can put the questions or push the questions in the chat box. And with over to you.
Hey, thanks, Srini. Sanil, maybe you want to take some questions on screen or over voice?
Yeah, I can. If any questions. Some questions I try to answer on chat. But if there are questions, more questions.
There is one question. Does Kahoot need a license and purchase, or is it free to use?
Yeah, all our projects in Soda Foundation are Apache v2. So you can freely use it, and Apache v2, as you know, it supports commercial deployment also. For example, you can download and you can create a commercial product out of it. It's free to use, completely free to use.
Just to download a project you are interested, follow the deployment or the usage guide and go ahead. And if some unclarity in guide, please you can connect us in Slack. If it is an issue with the guide, we'll update the guide. It will be helpful for others also. So please go ahead and try the project you are interested. Thanks.
Yeah, one important thing is that if the question is more towards a productization or something like that, as I mentioned, it's free because it is Apache v2. But we also do one more support from the community. That suppose a company or a team wants to deploy Kahoo into a real product or product environment, we can also support on the integration process. In the sense, you can say that what is your requirement and things like that, and you can because we'll be able to support from the Kahoo side, and you can support from the product side, so that we can work together to integrate successfully and then deploy it. So we can also support that.
Right.
Any other questions? Okay, so even if you have questions, you can join our Slack, sodafoundation.io/Slack, and then you can ask any questions. And we have dedicated channel for Kahoo, or every project we have a dedicated channel. So you can post your questions and we can start discussing. Once you join, you are among one of us and we can work together. Yeah, thanks.
Okay, thanks, Anil. If no other questions, then we'll just jump back. Praveen, are you there now? Are you connected?
Yes. With time there now.
So we will just see a hands-on demo of the CSI snapshot with the data management by Praveen Ranjan. Over to you, Praveen, whenever you're ready.
Okay, thank you, Anvit. Okay, so hello everybody. Again, sorry for last time network hiccups. So now I think network is good enough to show the demo. So what the Susant and Amit and other members were talking about the CSI part. So I will be talking or giving mostly the demo for the snapshot, how the CSI basically we are using for snapshot, and which are the way we can what are the examples, and what are the YMLs, and all those things are mentioned that we can discuss. Okay, so before going to that part, just I would like to show the demo for this driver, host path-based driver. And you can see that I have opened the Kubernetes CSI, one of the GitHub page, and I will try to explain a little bit about these examples and deployment, and then probably I will show the demo for the snapshot. So if we are talking about the snapshot technology, so must be two things should be installed on your cluster. One is the CRD, of course, it should be there, and the controller should be present. The deployment examples are mentioned here. You can see the documentation in the documentation, and if you read the thoroughly, then you will find that these are the some prerequisites there. For example, it should be Kubernetes 1.17 plus onwards, and some examples links are also given. So if you go to this volume snapshot link, then they have given some examples how you can use it and which are the components required. Even if you want to deploy, let's say, controller of snapshot and all, so those examples are also given. So just take a look. You can see here before, if you want to use the snapshot technology, there must be CRD and snapshot controller installed. You can click on this, and basically they have given the example how you can apply these YMLs to set up the controller and the CRDs. Okay, so now I have already followed these steps, so again I will not follow the same. So just I followed these steps to set up my controller, CRDs, and all those things related to the snapshot. Now I will go to quickly to my terminal, and so that this part is already installed. You can see that snapshot CRDs are there, and if you see the pods, then apart from these provisioners and all, snapshot controllers are also running in my environment. Okay, so these two prerequisites are met, and our Kubernetes version is also 1.25. So basically we are done for we are done with the prerequisite what it has been mentioned in this document. Okay, Now, just to show the example of this how snapshot works, and we'll try to create something so that we can show that snapshot is created and it is being ready. It is ready for use. So you can follow all these things, but you can follow all those things, and here there is a directory. You can see that examples. And in examples, there are so many YML files mentioned. Okay, some of the YML files are related to storage class, snapshot, PVC, pod, and all those things. So these are the examples for different use case. Now I will try to stick only with the snapshot. So for snapshot, 2-3 things required. One is as we know that the controller and CRD that is installed in my system. And then snapshot storage class required. So that is also I have already created. Volume snapshot class. If you see that I have already created this, and simply it's a very basic storage class. Nothing much more, or simply directly I can show the YML. Yeah, so there is no specific parameters mentioned, and driver we are going to use this, the host path CSI driver, and delete policy. So very basic storage class we have created, and that is now up and running. Once it is done, then now we can go and create another storage class for the PVC. So let's say now I will go to this directory and simply I will create this storage class. So just to show what is there in that CSI storage class. So this storage class will require to create a PVC. So again, I'm using this driver, host path CSI driver, and the basic name and all things mentioned in that. So I will create now, I will apply this storage class, so that storage class is now created. Okay, so this storage class is created. So just now, few seconds ago, it got created. Now I will go and I will to create the PVC. So since the driver is already up and running installed, so PVC and PV would be successfully created. So I will use the same example. So again, I can explain from here. If because the same YML file I will deploy. So we are storage class. This storage class we will be using this storage class, which is just now I created, and the basic things, read write once and just 1 GB storage. So these are the basic things. So I will go and create now those PVC. So I have already, you can see that I have already cloned this repo. So the same files is available in my repo, and simply I will create this. So now you can see that 4 seconds back, this PVC is now created. And if you describe this, so we are using the same host path driver, CSI driver. Okay, so now we are ready for, we have already created the storage class PVC, and now we can create this snapshot. So again, if you come to this snapshot YML, the same YML file I will deploy. So the name I will be giving as a new snapshot demo, and then the snapshot storage class I have already shown that it has been created, and this PVC I will be using that, which is just now I created few seconds ago. So all things are whatever the mentioned in this YML has been created. Only now volume snapshot is ready, means we are going to create this using this PVC. So source will be CSI PVC, which is just now created. So CSI PVC is now available. 4 seconds ago. So I am just going to create the CSI snapshot v1.yml, the same file which is there, CSI snapshot v1.yml. Now it is successfully created. We can see that. Okay, get volume snapshot. Okay, so 13 seconds ago it is created, and you can see that these are the namespace, name, and all. So new snapshot demo, the name of the snapshot is created using this PVC, and the size of this PVC is 1 GB, and the same snapshot class it is using the basic one what we have created, and the snapshot content also is I have already created. And now you can see that each and every detail it is ready to use. So this snapshot, now we have created the snapshot of this volume, the CSI, the PVC. Okay, and all these details is, you can see that basically in this output, that which are the source part we are using, and whether it is able to use or not. So you can say that it's ready to use. So this snapshot now we can use as a volume if you want in your application. So that's the main part of this snapshot. Again, I will try to show some more part like the restore. So again, this we can restore, we can do some cloning and all those things we can do. So basically what I'm trying to say that all these features related to the snapshot restore we can do using this driver. So quickly I will go to the restore part, and I will try to restore this volume, this snapshot. Okay, so if you see the difference, okay, if you see the description of this YML file, there are two things need to be checked. That the storage class, the same storage class we are trying to use, the CSI host path storage class, and then the kind means the data source is the data source is snapshot, not the volume or not some any other resource. So basically just now we have created a snapshot, and from this snapshot we are trying to restore back. Okay, that's the main point I wanted to highlight in this YML file, because the main thing just need to see here is that what the data source we are going to use for the restore. So whatever the snapshot we have created, we are going to restore using this snapshot. So again, I will apply this file CSI, and the file name is CSI restore.yml. So now it has been restored and PVC should be available. So you can say that from this CSI PVC, because the main overall the volume snapshot was created using this, and now we have restored it few seconds ago, 6 seconds ago. Okay, so the main difference between the normal volume provisioning and here restoring is that simply we are trying to restore from the snapshot, not from any other volume and PVC. Okay, so this is the about the restore. Again, you can perform the clone operation and other things. So for clone, we can create a new PVC and we'll try to clone that PVC. So that also quickly I can show. So I have already PVC YML. Simply I will go and modify a little bit name. Example CSI PVC. And here maybe I will give the name of clone. Now we can do the clone, and if you see this clone YML, you can see that we are going to use a persistent volume of this. So probably I will change the name of this PVC because just now I've created. So we can see the clone. So I'll replace this name, what we created just now. Right. So few seconds ago, this cloned PVC is also now created. So overall, what we have seen till now is we have created some snapshot. I'll show this again YML file. So we had created some we have created snapshot class. Okay. Then we have created a normal storage class. And then we have created the PVC. So for PVC, we need storage class. So storage class was deployed. Then PVC we created. And then using this PVC, we created this snapshot. And then we restored back using this snapshot. Again, we created another PVC and we tried to use this clone part. So using this CSI driver, I have shown all these 4 components, basically snapshot, restore, and cloning. So that's it from my side about the demo, what we have wanted to show from the snapshot side. If you have any questions and or maybe we can discuss. Anvit, over to you.
Hey, thank you, Praveen. Yeah, are there any questions or queries? If not, I think we've covered all the sessions, Sanil. Is there any other thing that you would like to cover? Maybe if you missed something or skipped something.
I think, yeah, I think we covered everything. Maybe we can open for some.
Yeah, any doubts, any queries, or if you just want to know something about what we've spoken today, just fire away. We have good enough time today.
Anything about our, whatever we presented, and also if they want to know about Soda and if they want to contribute or join, learn more about it. Anything we can discuss.
Hey, I need one question here. This soda can be used only on the volumes, or can it be used on the blob storage or the S3 storage to take the backups?
We support S3. Amit, we have completed the prototype, right? S3 support.
S3 support prototype is ready, but it is still under implement. I mean, it's going to be implemented. It is only considered for the like as a plugin. It has been only considered till now, but it as a backup storage, the implementation is not available. The plugin is not available basically.
So basically, are we targeting the release also, or it will be?
Yeah, this release it should be. Then the
okay.
quarterly release should be available. Yes.
Okay. So
I think Sanil, the question was about.
Yeah, I will just clarify. I know. Yeah, I'll just clarify. So see, basically, right now, your question was more on Soda, but Soda is a group of projects because Soda comprises of multiple different projects, and maybe your question is more towards Kahoo. Kahoo is a data backup solution. So whichever PVs are orchestrated as can be the source, and the destination part is what we are talking about. The backup destination can be S3, but that feature will be available in the release. So right now, out of the box, we support NFS.
Okay.
And I think CSI also we have the future ready, right? I mean,
Yeah, it is ready.
yeah. So any storage which can support CSI, yeah, of course you can use it.
It is mainly the persistent volume, the source volume, and whatever we are discussing is like destination, like where we can put. So those are some
Correct.
of the options which Sunil mentioned. But what we backup is, if that is the question, then it is for the persistent volume, which may be created out of any of the backends through CSI or through in a Kubernetes system.
Okay. So if the destination is down for some reason, is it capable to do the caching meanwhile the destination comes back online?
Yeah, could you
Yeah,
please
actually
No, yeah.
destination. Yes. Destination, like if you are supposed to put a resource, say an FS or S3, and S3 is not available, so the life cycle will take care, like it will keep trying to place this at S3 location, and it will also check like whether S3 is available, and it will keep checking the availability of the storage, and it will be trying for that.
Yeah, but to answer the question, caching is not supported till now.
Okay.
Yeah.
We don't cache, but we just run our life cycle such a way that we make an attempt to place it, and meanwhile we also try to probe and see the availability.
Okay.
So basically, Shazid, the solution is such a way that the backup location, right, is a pluggable entity. So if you want like a caching system in between your backup location and the plugin, right, you can have your driver in such a way that it in between it can use cache. So
Yeah.
the pluggability
Yes.
supports that functionality. But yeah, straight away, if you saying in the architecture it has been considered, it's not.
Okay.
Yep.
Good. Thank you.
Yeah, and with there is, I think it looks like there is no question. More questions.
All right. If that is the case, thank you everyone for attending this workshop on container data storage by the Soda Foundation. Thank you to all the speakers. Thank you, Savita, Amit, Sushant, Praveen, Sanil, and Srinivas. And thank you very much to the team at KCD. Thank you, Avinash, and thank you, Namya, for this amazing event. Looking forward to meet you all in person for the KCD event, the Kubernetes Community Days event on June 2nd and 3rd. Is that right, Avinash?
Yes, correct.
So 2nd and 3rd of June, that's when we'll be able to meet in person for Kubernetes Community Days. Until then, this was the workshop. These are some important links which you can just take a look at. These are the links for the Delphin, the multi-cloud, that is the Strato project, and the Kahu project. You can also get in touch with us on the Soda Foundation Slack by going to sodafoundation.io/Slack. And then a few more important links just to get you. You can also follow us on Twitter by going to twitter.com/sodafoundation. You can check out the documentation website for all the projects, which is docs.sodafoundation.io. Please do follow us on LinkedIn. You can just do a bit.ly/soda-LinkedIn. And also our YouTube channel is bit.ly/soda YouTube. All these links are available in the Soda Starter, the link which was shared at the beginning. I will also share this in the chat now, but maybe the starter would be the best place to start off. With that, thank you so much for attending this workshop. Have a great evening and have a great weekend ahead. It's a long weekend, so enjoy yourselves.
Thank you. Thank you all.
Thanks,
Thank you.
everyone.
Yeah, thank you everyone.
Thank
Bye
you
bye.
all. Bye-bye.
Thank you, everyone.